Hi, in this episode I'm going to look at some techniques and strategies to help you when you're doing calculations, specifically with projectile motion style calculations. Traditionally you get, in a projectile motion question, you get the angle at which the projectile is launched, and sometimes you'll also be given the initial velocity with which it is launched. Before proceeding with your calculation, you should list all data that has been provided and all data that is required. But with a projectile motion, we should split that data into vertical and horizontal components. Now in the vertical direction we know that the acceleration due to gravity is 9.8 meters per second down. We also know in this instance, if we're neglecting any air resistance, that being a symmetrical path, the vertical displacement will also be 0 meters. Splitting up the initial velocity into vertical and horizontal components, we get that the initial vertical component is 125 meters per second and the initial horizontal component is 216.5 meters per second. What we don't know is the time. Now the time will be the same for both vertical and horizontal because it's the one object, and we also don't know the horizontal displacement. Because in the vertical section we only have one unknown, we'll concentrate on that section first and solve for the time. If we put all of the data that we have, that is the displacement, the initial velocity, the acceleration and the unknown time, into the equation s equals ut plus a half at squared, we can solve for time and find that the time of the flight was 25.5 seconds. Now we can place that piece of data into the horizontal section of the work. Now we only have one unknown, which is the horizontal displacement, or the range, which is what we're trying to find. Because the horizontal velocity is constant throughout, as there is no force acting against it or with it, we can just use the displacement equals velocity times time and find out that the range was 5.5 kilometers. So summarizing, we split the data into vertical and horizontal. We solve for the side that has one unknown first, and then we substitute that data into the side that has two unknowns, and then we solve for that side. You don't always get all of the data that's been provided in this question, however. In this instance we've got a golfer hitting a golf ball again at 30 degrees, but we're just told at some initial velocity, and we're told it has to have a required velocity to just get over a 12-meter tree, which is 40 meters ahead of the golfer. Again, we do the same sort of thing. We split into vertical and horizontal components. We find that the initial velocity in the vertical direction was 0.5 u up. The vertical displacement we're requiring is 12 meters, just getting over the tree. And again, the acceleration is 9.8 meters per second down. So I've given that a negative value. In the horizontal direction we use the same component, that is 0.87 u for the horizontal velocity. The horizontal displacement is 40 meters, and the time again we don't know. If you look on both sides of the data, there are two unknowns. There is u and t on both sides. So in this instance where you've got two unknowns, we'll have to use simultaneous equations to help us solve it. I've chosen to look at the horizontal side first, just because there's no squareds in the equations we're using, and I get an expression for t expressed as a value of u as 40 on 0.87 u. Now I can substitute that value for t into the vertical side of the data, and once it's in there and that's substituted in the s equals ut plus half at squared equation, it's a bit of mathematics, but we get down that the initial velocity had to be 30.7 meters per second, and that's at the angle of 30 degrees to the horizontal. All calculations should be done in this way, that is, listing the data that is required, the data that is given, and what equation relates all of that data.